All right. So, good day, student. Welcome to today's session. Now, in today's lesson, we want to look at the Poisson distribution. Right. In fact, this is under probability and statistics. Yes. So, grab your pen and then your book, and let's have some studies. Now, we want to define Poisson distribution, and the definition says that a Poisson distribution is a discrete probability distribution that gives the probability of an event happening at a certain number of times k within a given interval of time or space. So basically with Poisson distribution, we are looking at finding the probability of an event that is happening a number of times, right? And here we represent the number of times with the variable k. Now this event is happening a number of times within an interval of time, within a given interval of time or a space, right? So we can have a lot of examples of Poisson distribution. If you want to know the number of calls that maybe a telco receives within a week, is an example of a Poisson distribution, right? Under Poisson distribution, here they want to find out the number of calls that come in from the customers within a week. So the particular time or the given interval of time here is the week, and then the number of calls that comes in within that time interval is the event, and we can find the probability of such an event. So basically that is what Poisson distribution deals with. Now we mostly use Poisson distributions when we have these two things. One, the individual event happen randomly. So take note, the individual event happen randomly, and then they are independent, randomly and independently. Of course, you remember what an independent event is. When two events A and B are independent, what it means is that the occurrence of one does not affect the occurrence of the other, right? One occurring does not have any effect on the chance of the other event occurring. So here the individual events happen randomly and then independently. The second thing is that you must know, so you know the mean of event occurring. So you must know the mean of the event occurring, right, within a given interval. So within a given interval. So two things you must take note before you use the Poisson distribution. The event must occur randomly and they must be independently. And so they must be independent. And then you should know the mean of events that is occurring within a given time interval or within interval of time. Now here the mean is assumed to be constant. We assume that the mean is constant, right? If you don't see mean, you will also see average or the expected outcome, the expected number. All these words refers to the mean. Now let's look at mathematically the formula for the Poisson distribution. So mathematically, this is the formula given to a Poisson distribution. So P into bracket random variable x equals small x, which is equal to e to the power. If I need to let me clear this from there. Let me clear this particular one from there. So this is equal to e to the power negative lambda times lambda to the power x all over x factorial. So mathematically, this is the formula given to Poisson distribution. It is e to the power negative lambda and then lambda to the power x all over x factorial. Here lambda is what we call our mean or the average. If you don't see mean, you can see average or expected value. So the lambda is the mean of event occurring within a given interval of time. So whenever there is a question under the Poisson distribution, you first have to try to locate your mean, because that is what you are going to use to solve the question. So quickly, we are going to look at two examples. We will solve two examples. We will use the formula for Poisson distribution to solve two examples. So in example 1, we are given that an average of 0.61 pedestrians died by road accident per year in Accra. Find the probability that exactly 2 pedestrians died by road accident in 2024. So this is a typical Poisson distribution question. We are going to use the Poisson distribution to find the probability that exactly 2 pedestrians died by road accident in 2024. So here, the question you have to ask yourself, that what is your mean? Don't forget that in the formula, probability of x equals this. Oh, this should be k, right? Because we say the number of events k. Yes. So in the previous example, this side, so we have k here instead of x, because we indicated that a certain number of times happening within a certain number of times. So the number of times is k. So x should be equal to k. Now this formula is given as e to the power negative lambda times lambda to the power k over k factorial. So if we are using k, then this side is also going to be k, and we are going to have k factorial. However, the variable doesn't matter. Whichever variable you want to use, you can use it. So this is the formula. So here we need to get our lambda. Don't forget the lambda is the mean. And from the question says an average of 0.61. So the mean is given as 0.61. And then our k, that is what we want to find. The probability we want to find. The k is 2. Because the question says find the probability that exactly 2 pedestrians died by road accident in 2024. So this is what we want to calculate. P of x is equal to 2. Now e to the power minus lambda. Lambda is 0.61 times lambda, which is still 0.61 to the power k, and here our k is 2, all over 2 factorial. So we need to do simple simplification here. Now the question is, what is e to the power? Now you know the e is on the calculator. If you have the scientific calculator, you will find the e there. So e to the power negative 0.61 will give us 0.5. Will give us 0.54. Let me leave it to 4 decimal places. 0.5434. Then times. Now 0.61 squared is going to give us 0.3721 all over 2 factorial. Of course, 2 factorial is 2 times 1, if you remember. So now we try to multiply the numerator. So 0.5434 times 0.3721, that is going to give us 0.2022. I will be leaving my answers to 4 decimal places. This divided by 2. So 0.2022 divided by 2 is going to give us 0.1011. So this is the probability that exactly 2 pedestrians died by road accident in 2024. So you use the formula here. We are looking at 2 accidents that occurred in 2024. So our k is 2. Then the mean was given in the question. I told you that if you don't see mean, you will see average. The question said an average of 0.61 pedestrians. So our mean is 0.61. So we just need to substitute the value of lambda and then the value of k into our formula in order to get a probability. And that gives us 0.1011. We can interpret this as approximately 10.11 pedestrians died by road accident. Right? 10.11% of pedestrians died by road accident. That is the interpretation. Let's look at the next example. Alright, so in the second example, I want you to pause the video and then try it on your own, work it out yourself. Then you can come back to the video to compare your answer. Alright, so now I believe that you've tried it on your own, you have done something. Let us try to solve it together and then we compare our answers. So in this example 2, In this example 2, we are told that the number of misprint in a book of 800 pages is 1600. Assuming that the number of misprint per page follows a Poisson distribution, find the probability that a particular page contains exactly 3 misprints. So even in this question, you are even told that the number of misprints per page follows a Poisson distribution. So at least you have the idea, or you get to know that you are dealing with what a Poisson distribution. In the first example we did, there was no statement like that. However, some information in the question will guide you to know whether if you are supposed to use the Poisson distribution. Alright, so here let's quickly put down our data. What is our mean? We need to calculate the mean. Now look at this thing. The number of misprint in a book of 800 pages is 1200. So the book has a total page of what? 800. And then the total number of misprint in the book is 1600. And you remember how to find the mean, right? So this is going to be 1600 divided by what? 800. Of course, this is going to be 2. So we have our mean, which is the lambda, to be 2. And then our k is 3, because the question says find the probability that a particular page contains exactly 3 misprints. So our k is 3. Now the formula for the Poisson distribution will be x is equal to 3. And then this is equal to, we are trying to find the probability that this is equal to 3. So e to the power negative lambda, and our negative lambda is, our lambda is 2, so minus 2, times lambda to the power k, which is what? 3, all over k factorial, which is 3 factorial. So here, this is basic simplification. We need to find what e to the power negative 2 is. Now e to the power negative 2 is given as 0.1353 times 2 to the power 3 is just 8, and then 3 factorial is 3 times 2 times 1. So what is 8 times 0.1353? And that is 1.0827. So let me clear this decimal point and write it well, because where is it? Yes. So let me write it well. So that is 1.0827 divided by, what is 3 times 2 times 1? That is just 6. So 1.0827 divided by 6 will give us 0.18045. So this is the probability that a particular page contains exactly 3 misprints. The answer is 0.18045. If you are not told to leave your answer in any specific decimal place, then I will advise you to leave it in 4 decimal places. Now this can be interpreted as 18%. So there is 18% probability that a particular page contains 3 misprints. That is the interpretation. Alright, so compare it with what you did. Did you get the same answer? Let me know in the comment section. Let me know if you got the same answer. If you didn't get it, is fine. Try it out again and then solve a number of good questions and you will be okay with it. Alright, this brings us to the end of today's lesson. And in today's lesson, we learned the Poisson distribution, but how to compute probability using the Poisson distribution. I gave you the formula and then I gave you 2 examples to try your hands on. Thank you for joining me today for today's session, and I hope to see you in the next session. Make sure you like, share, and then subscribe to this channel so that whenever I upload any new lesson, you will be notified. Have a nice day.